this video is to look at ellipses. And so in this section here, we give, I guess, the definition of an ellipse. And it does look very similar to a circle, right? Where we have this idea that ellipse has a center, h comma k, and similar to a circle, we think about it as like a radius squared, right? So here's h minus or x minus h squared. Here's y minus k squared. But we set it equal to 1, right? And so we want that equal to 1. And we could have different coefficients a and b underneath those particular functions or particular squares. Okay, so we think about this ellipse has a major axis or a minor axis going along either the x or the y based on those lengths. And so it sometimes is best to maybe just like jump in and look at an example. So like for example, number 1, it says, sketch the graph of x squared plus y squared, or x squared over 25 plus y squared over 9 equals 1. So what I'm thinking of is that there are a couple of key features that tell me this is an ellipse. We've got two squares, x squareds and y squareds, that we're adding, and it's set equal to 1. And so I know that it's going to be an ellipse. And another thing I'm going to notice is that since each of these values are just x or y by themselves, we know its center must be at 0, 0. We're not shifting things to the left or the right, like maybe in the following example, we might be. Okay, so, and then what I'm going to do is take a look at this 25. 25 represents a squared, the larger coefficient. So I know a is going to be plus or minus 5. We're going to think of it as a positive value. So in the x direction, I'm going to go out 5, and we're going to put an endpoint, and 5, and we're going to put an endpoint. And then similarly, 9 is in the y direction. So 9 is going to represent our b squared value. And so our b is going to be technically plus or minus 3. We're going to think of it as a positive value, as a distance. So 1, 2, 3, 1, 2, and 3. Okay, so there are our endpoints of our major axes, minor axes. So what I'm going to do is draw an ellipse. I'm going to draw an ellipse that has those dimensions that fits that particular sort of like endpoints. There we go. Now, unlike polar, ellipse doesn't have any kind of direction, like you have to draw arrows or star the start like we're used to. Okay, but here's my ellipse. Sorry, it's kind of little. Trying to make it a solid line. It kind of got a little crazy. Okay, so major axes. The major axis is the longer axis. In this case, it's the direction of the x. So the major axes would be 2 times 5, or the major axis would be 10, or a length of 10. Where the minor axis, in this case, the smaller direction, or the smaller length, is in the direction of y, and that has a length of 6. And again, that 10 and the 6 each represent double the a or the b. 6 represents 2b, and then 10 represents 2a. Okay. So it's kind of like a circle with radiuses in different directions. One length, one the other. Okay. Similar. Number 2. So start at the center. So center your ellipse. So you look for where the zeros of those particular coefficients are. So x plus 1. That means the center is at negative 1. And then y minus 4, 4. So my center is at negative 1, 4. So I put a little dot there for the center. And notice the center of the ellipse isn't on the ellipse, right? I mean, that might seem like an obvious thing, but the ellipse itself is only the perimeter. Okay. So now in the x direction, we see 4. So in 4 is the smaller of the two numbers. So in this case, that represents b squared, which means b is plus or minus 2. But we're going to think of it as a positive value because it's a distance. So 2, or you could think 2 to the right and 2 to the left. So there's an endpoint, and there's an endpoint in the x direction. And then in the y direction, we're going the square root of 16, which is 4. So my a squared is 16. So a is 4, plus or minus, but again, one above, one below. Now, I realized that I ran out of room. That was kind of not good job, Mr. Brown. So we go up 4, 1, 2, 3, 4, so we tenths there. and we draw our ellipse. So again, just kind of drawing this circular figure. Doesn't really matter the order. And then we have our ellipse. And if I think about the major axes, it's the longer of the two axes. It's always equal to 2a. So in this case, 2 times 4 is 8. And our minor axis is 2b. So 2 times 2, which is 4. So major axes, minor axes. 4 equals 2b, where 8 is equal to 2a. Okay. Now, you could certainly try one, pause the video, see if you get the same thing I do, or follow along, doesn't matter. But this one looks like it's centered at 0. X comma y center would be 0, 3, because of what makes those each points 0. So 0, comma 3. So here's our center. Oops, make sure I did. Yeah. For some reason, I just wasn't. I thought I mixed up the x's and the y's. Okay, so 0, 3. And then, because 25 is the larger of the two numbers, 25 represents a squared, which means 5 is equal to, our a value, or plus or minus 5 is our a value. So in the x direction, we go out 5, we go out 5, and then the square root of 4 is 2. So 4 represents b squared, so we go up 2, down 2, and we draw our ellipse. So here we go. Oops, there we go. Draw our ellipse. Now, ellipses, like circles, like I said, have x squared plus a y squared, or a y squared plus an x squared. And circles, x squared plus y squared. But you could make an argument that circles are like ellipses that have the same radius in both directions, right? Okay. Major axes would be 2 of these 5s, which is 10. You can clearly see that major axes is 10. And then 2 of the 2s, which is 4. Okay. Now, you might say, well, what if it's not equal to 1? Divide, right? It's so easy. Just divide. Divide. Now, you'll notice, excuse me, if you already started working ahead, this comes out very nice. Because 16 divided by, or like 16 over 144 will give us a 9. So now we have x minus 3 quantity squared over 9. And then 144 divided by 9 is 16. So that becomes y plus 2 squared over 16. And that equals your 1. Great. So now we see its center. The center is at 3, comma, negative 2. So I'm going to go over 3 down negative 2. There's my center. And then, in this case, y is the larger value, or the y squared of that. So 16 in this case is equal to a squared. So I'm going to go plus or minus 4 in the y direction. Put a point there. Put a point. Oops. Go down a little bit more. There we go. There. And then 9 would be my b squared value. So square root of that is 3, or negative 3, depending on left to right. And we can draw our ellipse. We're going to try something different. What if I make it just a little bit thicker? Maybe that'll make it smoother. We're going to find out together. I don't know. What do you think? Maybe better? Well, I think so. Look at that. Oh, I like it. Okay. So, again, major axes, minor axes, thinking about, 2a and 2b. In this case, 2a is 2 times 4, which is 8. 2b is 2 times 3, which is 6. Okay, now last example, kind of like an application, or trying to create this equation. So it tells us the lengths of the major and minor axes of an ellipse on the ratio of 4 to 3. And so, well, first of all, 4 to 3 doesn't necessarily mean it has to be just 4 and 3. So I'm going to say 4k and 3k, right? Because maybe it's 8 and 6, or 40 and 30, or 2 and 1.5. So having that k allows us to have that scale factor. Okay, and it does say that it's the major to minor. So the major axis we think of as 2a, the minor axis is 2b, or if the 2's cancel, we could say 4k to 3k is equal to a to b. Great. Now, it does say the major axis is the y-axis, and it does tell us that it contains a particular point and that it's centered at the origin, which is pretty helpful. So the fact that it's centered at the origin allows me to say it's going to be x squared like plus y squared, not having anything that you're subtracting. So x squared plus y squared equals 1. And then you might wonder, okay, what goes under the, does the 2a go under the x, or does the 2b, or so because the major axis is in the y-axis, we know that that has to be our a squared, and then the minor axis becomes b. Perfect. And then what I might do is take a look at this, and let's maybe do a little bit of cross multiplication. So, for example, if I multiply like across, and now our k's would technically cancel, so I could think about that as 4b. I multiply this across equals 3a, and then just realize that every b is equal to 3/4 a, right? Dividing the 4 across. So that might be helpful. If I know what b is equal to, I could put that in right there. So I have x squared over 3/4 a, or 3a over 4 squared, plus y squared over a squared is equal to 1. And then last, let's put in our -3 and our -3/12 for x and y. So -3 squared over, and we can certainly simplify. That's 9a squared over 16 plus 12 squared, which is 144. My computer is not like that slow. Over a squared equals 1. So let's do some simplifying here. 9 divided by 9a squared over 16 plus 12 squared is 144 divided by a squared is equal to 1. And we can move this 16 up here. So we get 16 times 9 is 144 over 9a squared plus 144 over a squared is equal to 1. It might make sense to multiply both sides by 9a squared to get rid of the fraction. So that gives you 144 plus the a squareds cancel, so 9 times 144 is equal to 9a squared. Well, 144 plus 9 times 144 is 10 times 144, which is equal to 9a squared. And then certainly if we divide by 9, 145 by 9 is 16. Oops. So 16 times 10, which is equal to 160, equals a squared. Now, no panic. It's okay that that's not a perfect square, because in our final equation, if you take a look, we want a squared, which is exactly what we got, right? So we can replace a squared with 160. And then for our b squared, since we know that b is 3/4 of a, and if I square both of those, so that means b squared equals 9/16 of a squared, and we know what a squared is. We could easily find b squared. So b squared is equal to 9/16 of a squared, which is 160. And that goes in there 10 times, so we can say b squared is equal to 90. Okay, so then our final answer is x squared over 90 plus y squared over 160 is equal to 1. Has the right ratio of a to b for the major to minor axes, but then also contains the correct point, -3, 12. Okay, so hopefully that helps. And again, just as an introduction to ellipses, and what we can think about them is they're kind of like circles that have been stretched in two directions, or you have two different radii for the major and the minor axes.